so C1 says, for every integer n greater than or equal to 2, there is a number system with base n where the integers are written using the digits 0 to n minus 1. They give you an example, which is hexadecimal. A string of digits a, b, c in the system with base n represents the positive integer an squared plus bn plus c. Okay, I'm gonna skip all of this. So part A says write the base 10 number 2025 in base 5. So to do this, we follow the instructions that they give over here. So they give you the example ABC and base n is an squared plus bn plus c, right? So we can write 2025 over here in the same format where n is equal to 5. So the biggest power of 5 that is less than 2025 would be 5 to the 4, which is 625, right? So we know that 625 times 4 is 2100, which is greater than 2025, but 625 times 3 is less than 2025 because it's like 1875, right? And so 2025 would be 625 times 3 plus 150. And then you can write this as 625 times 3 plus the next biggest power of 5 that is less than 150 would be 5 to the 3, which is 125. And so this would be plus 125, and obviously 125 can only go once before 150 minus 125 is less than 125. And then you're left with 825. And so we can write this as 5 to the 4 times 3 plus 5 to the 3 times 1 plus 5 to the 2 times 1. And so then 2025 would be equal to 31100 in base 5. So what this represents is 3 times 5 to the power of 4 plus 1 times 5 to the power of 3 plus 1 times 5 squared plus 0 times 5 plus 0. And that is what 2025 is. So that is part A. Okay, part B. Solve the equation that written in the hexadecimal system. The answer should be given in the hexadecimal system. So we can first convert this into decimal, right, which is base 10. So let's first assume that we have x, which is in decimal already. So we have x squared, and then we have 20 in base 16, which is equal to 2 times 16 plus 0, which is 32x. And then you have AF. So we can write that like over here. So AF in base 16, this would be equal to A times 16 plus F, which is 16 times A plus F. And then we know that A is 10, F is 15. And so this is 175. So our quadratic would be x squared minus 32x plus 175 is equal to 0. And then we can factor this like we would normally factor a quadratic function, or I guess equation. So this would be x minus 25, x minus 7 is equal to 0. And so our answers would be x is equal to 25 and x is equal to 7. So then we convert this back into hexadecimal. So 7 is obviously just 7 in base 16. And 25, you know that is 16 plus 9. And so this is 19 in base 16. And so these are our two answers for x. Okay. Finally, part C. In what systems with base n is it true that 24 divides 2000? So once again, we can convert both of these into base 10. So 24 in base n would be equal to 2n plus 4. And 2000 in base n this would be equal to 2n cubed. And so what we have is that 2n plus 4 is a factor of 2n cubed. So we can write this as 2n cubed over 2n plus 4 is an integer, right? And so we can, so we can have on the numerator here, you can add a 4n squared, and then you can subtract a 4n squared, and this would still give you 2n cubed over 2n plus 4. And so now you can factor out an n squared, and then you can add, or I guess you're subtracting now. So subtracting 4n squared over 2n plus 4. And you know that this is an integer, which means that this part has to be an integer, or I guess this has to be an integer. And you can rewrite that once again. You can add an 8n and then subtract an 8n, and then you can sort of factor it out again, and then you would get 2n minus 8n over 2n plus 4. And once again, you have that this is an integer, which means that this has to be an integer. And so 8n over 2n plus 4, you can add and then subtract a 16. And so then this would give you 4 minus 16 over 2n plus 4. You know that 4 is an integer, which means that this part has to be an integer. So now you have 16 over 2n plus 4 is an integer, which means that 2n plus 4 is a factor of 16. So 2n plus 4, you know that n has to be positive. And so 2n plus 4 can only be the positive divisors of 16, which are 1, 2, 4, 6, 8, and 16. Okay, and for the ones that give you an integer value of n, we have 4, which gives you n is equal to 0. We have 6, which gives you n is equal to 1. 8, which gives you n is equal to 2. And 16, which gives you n is equal to 6. And now we see that over here we have 24 in base n, which means that n has to be greater than 5. Greater than or equal to 5, right? Because otherwise we wouldn't have a 4 in base n, because the definition up here says in base n you can only use the digits 0 to n minus 1. And so we know that n is greater than or equal to 5, and over here the only n that satisfies this is n is equal to 6. And so our answer to C is 6. Okay, so that is C1. Moving on to C2. In mathematics, an anagram of a word is a rearrangement of its letters, including those that result in nonsensical words. So part A, how many anagrams of the word tenet start and end with T? So we know that it has to start and end with T, so it's T, and then you have 3 spaces, and then the other T. And you know that in the 3 spaces, it is a permutation of the letters E, and N. And so to sort of permute the letters, we have 3 letters, which is 3 factorial ways, and of those 3 letters, you have 2 of the same, which is an E. So you have to divide by a 2 factorial, because, for example, E1, E2n, and E2, E1n are the same permutation. So this would give you 6 over 2, which is 3. So there are 3 anagrams of the word that start and end with T. For B, how many anagrams start and end with O? So once again, you can have an O and then 4 spaces and then the other O. And in between, so in these 4 spaces, you would have a Y-O-H-O, right? So this is 4 letters to permute, and then you have 2 of the same letter, so you divide that by 2 factorial, and this would give you 12, which is 24 over 2. Okay, so that's B. And finally, C, let n be the number of anagrams off the word abracadabra, which start and end with different letters. Find the largest prime number that divides n. So to do this, we can count using complementary count, sorry. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So we can write that out, 11 letters. We have how many A's? We have 5 A's. We have 1, 2 B's. We have 2 R's. We have 1 C, and we have 1 D. So in total, we have 11 factorial over 5 A's, 2 B's, and 2 R's ways to permute abracadabra without any restrictions. And then we want the start and end to be different letters. I'll write total here. So case 1, which is one, it starts and ends with A. So you have A, and then you have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A. And then in those 9, you would have 9 letters to permute, and then you have 3 A's remaining, 2 B's, 2 R's, 1 C, 1 D, which we don't have to write. So this is 9 factorial over 3 factorial times 2 factorial times 2 factorial ways for your anagram to start and end with A. So case 2 would be it starts and ends with B, so B, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, or not A, sorry, B. Okay. And then for this, your numerator would still be 9 because you still have 9 letters remaining. And then your denominator, you have 5 A's remaining, you have no B's, you have 2 R's, and then 1 C, 1 D, which you also don't have to write. And so that's 9 factorial over 5 factorial times 2 factorial total. And case 3 is the same as case 2, but you start and end with an R. And so this would still be 9 factorial over 5 A's and 2 B's left, and then you have 0 R's, 1 C, 1 D. So that would be 9 factorial over 5 factorial times 2 factorial. And these are all 3 cases that we have to consider because for the C and D, we have 1 of each, which means that we can't start and end with a C, and we can't start and end with a D. And so N would be, if we complementary count, we have the total, which is this, and then we subtract 9 factorial over 3 factorial, 2 factorial, 2 factorial, and then we subtract 9 factorial over 5 factorial, 2 factorial, and then we subtract 9 factorial over 5 factorial, 2 factorial. And then we calculate this, so we can factor out a 9 factorial first, and then the first term we would have 11 times 10 over 5 factorial, which is 120 times 2 times 2. For the second term, we would have 9 factorial out of the numerator, so we would have a 1, and then the denominator would be 6 times 2 times 2. And then for the third and fourth, we would have a 1 in the numerator, and then 120 times 2, so 120 times 2. And then we can start simplifying this. So this would give us 11 over, we can remove a 0, so this would give 48, and then minus 1 over 24, minus 1 over 240, minus 1 over 240, which is 1 over 120. And then this is 9 factorial, and then your common denominator would be 240, and then your numerator would be 55 minus 10 minus 2. And so this would be 9 factorial times your denominator is 240, your numerator would be 43. And then I guess you can get rid of the denominator if you wanted. So 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 43, and then you divide that by 240. So you can get rid of the 240 by getting rid of 5, 2, 4, and 6. And so n in the end would be equal to 9 times 8 times 7 times 3 times 43. And we can obviously see that the biggest prime divisor of n is 43. And so that is our answer for C2. So yeah, that is C1 and C2.